Your FastAPI application is already running, but now you need to add AI-callable tools without rewriting your entire backend. We'll show you how to mount a FastMCP server directly into your existing FastAPI app, exposing new /MCP endpoints alongside your current routes, all while keeping your original API fully functional. The pattern uses FastAPI's built-in mounting system to merge both servers under one domain.
From FastAPI, import FastAPI. From FastMCP, import FastMCP. Hash your existing API. API equals FastAPI. At API, get /API/status. Def status. Return status. OK. Hash create your MCP server. MCP equals FastMCP. API tools. At MCP, tool. Def query database query. SDR, dict. Run a database query. Return result. Data. Hash mount MCP at /MCP. API mount /MCP MCP HTTP app. Hash run with Unicorn app. API host 0000 port 8000.
This demonstrates the ASGI integration pattern, where a specialized service, FastMCP, is embedded as a sub-application within a larger web framework. The concept treats the MCP server as a modular component rather than a standalone service, allowing it to coexist with existing HTTP endpoints under a shared domain and deployment pipeline. What makes this distinctive is the clean separation between MCP tool definitions and the hosting framework, achieved through standard ASGI mounting. The pattern works by leveraging ASGI's composable application model, where each mounted app maintains its own routing and middleware while sharing the same server process. FastAPI handles traditional REST endpoints at /API/status, while the mounted MCP server at /MCP processes tool calls via the MCP protocol, both served through a single Unicorn instance. This design preserves the independence of each subsystem, while unifying deployment, authentication, and scaling under one umbrella. This approach solves the problem of service fragmentation, where related capabilities, traditional APIs, and AI-callable tools would otherwise require separate deployments. It's particularly valuable when you need to expose both human-facing APIs and machine-facing tools from the same codebase, or when integrating MCP capabilities into an existing web application. The trade-off is slightly increased complexity in routing configuration, but the benefit is a unified architecture with shared infrastructure and simplified operations. Let's break it down.
From FastAPI, import FastAPI. From FastMCP, import FastMCP.
This imports FastAPI for building the web API and FastMCP for creating AI-callable tools. The combination lets you expose both traditional REST endpoints and AI-accessible functions in one server.
Hash your existing API. API equals FastAPI.
This initializes the primary FastAPI application instance. It serves as the route router for all HTTP endpoints, including both your existing API routes and the mounted MCP tools.
At API, get /API/status. Def status. Return status. OK.
This defines a basic health check endpoint at /API/status. It provides a simple way to verify the API is running, returning a JSON response with status OK. This is a standard pattern for monitoring and load balancer checks.
Hash create your MCP server. MCP equals FastMCP. API tools.
This instantiates the FastMCP server, the core component that bridges Python functions to AI tools. The API tools String names this toolset, which appears in AI tool listings and logs. Without this, no functions would be exposed to the AI system.
At MCP, tool. Def query database query, SDR, dict. Run a database query. Return result, data.
The @MCP tool decorator registers this function as an AI-callable tool. FastMCP converts the type hints and docstring into a structured schema that AI models use to understand and invoke the tool. This pattern creates a clean boundary between your implementation and the AI interface, ensuring tools remain discoverable and self-documenting.
Hash mount MCP at /MCP. API mount /MCP MCP HTTP app.
This mounts the FastMCP server as a sub-application under the /MCP root path. It integrates AI-callable tools into your existing FastAPI app, preserving separate routing namespaces while sharing the same HTTP server. The pattern enables clean separation between your main API and AI tool endpoints.
Hash run with Uvicorn app, API host 0000 port 8000.
This is the Uvicorn execution command that launches your FastAPI server. The app API targets your FastAPI instance, while host 0000 exposes it to network requests, and port 8000 sets the listening port. FastMCP hybrid integration. This pattern bridges REST and MCP worlds by mounting a FastMCP server alongside existing FastAPI routes, exposing Python functions as AI-callable tools while preserving traditional HTTP endpoints. The mount path /MCP creates a distinct namespace that prevents root collisions between your API and MCP tools. A single Uvicorn instance now serves both human and machine clients from the same process.
The endpoint that serves two masters answers to neither, yet satisfies both.